Positive anode. So panic means positive anode, that is the anode is the positive electrode, while negative is cathode, that is panic. Positive anode, negative is cathode. So when you talk about the cathode, it's the negative electrode and the positive electrode is the anode. Alright? Then what does K, what does it stand for? It means anode. Now, hello, you're welcome to class today. Let's talk about electrolysis today. I'll be looking at the introductory aspect of electrolysis. But before I proceed, if you have not subscribed to our channel, do well to go and hit the subscribe button right now before we continue in this class. I'm going to give you time to do that. Have you done that now? And in case you have subscribed already, I want you to hit the notification bell so you can be notified anytime we post new content. And do well to comment, to like, to share with your friends. Alright, welcome to class. Today, let's talk about electrolysis. Now, electrolysis, what does it mean? Electrolysis is the compound word, a combination of two words. You have electricity, and lysis. Or you can as well say electrons and lysis. Lysis, so electricity means electric current has to pass through this system. And then when we talk about lysis means breaking down, or splitting. So anytime you hear the word lysis in maybe biology, alright, or for example in biology we have photolysis. Photo means light, lysis means splitting of water molecules in the presence of light during photosynthesis. That is photolysis. When you say catalysis, splitting in the presence of catalyst. Alright? So when you say hemolysis, hemo means the red blood cell, okay? The hemoglobin in the red blood cell, when it breaks, splits, lysis. Alright, so when you say electrolysis, that means you are breaking down a particular compound in the presence of electricity. So let's take, for example, before we begin to look at certain definition of terms, if you have your sodium chloride is your table salt. That is the salt that you use for your cooking in the kitchen. Now, you've always heard and learned that sodium chloride consists of two elements, which is sodium and chlorine. But when you scoop your sodium chloride, you cannot see the sodium, you can't see the chlorine. So how can you be sure that it's actually made up of sodium and chlorine? This electrolysis is actually a chemical process by which you can split that sodium chloride into the constituent elements. And that's why you make use of electrolysis. So if you want to enforce the splitting of that compound into its constituent ions and then elements, you can do electrolysis. So by the time you take this through electrolysis, it's going to split this into sodium ion and chlorine ion, and you will see in that setup, you will see where the chlorine ions where they accumulate. You see where the sodium ions accumulate. Alright, so that is what electrolysis is, the breaking or chemical decomposition of a compound when direct current flows through it, in its molten or aqueous state or aqueous solution. Now take note of that. First thing is, it is the breaking down or chemical decomposition, splitting decomposition of a compound when DC, direct current, flows through it. So some textbooks will just say when current flows through, or when direct current flows through it in its molten or aqueous state. So take note of these two, aqueous or molten. They are not the same. When you say aqueous solution, for example, if you take your sodium chloride, which is table salt, dissolve it in water, you have a solution, you have the salt solution. That is an aqueous solution. But when I have, maybe if I melt candle, I have the wax, right? Or if you prepare pap, that is like the molten state, right? When something melts. So when you say molten state, water is not involved. But when you say a solution, that means you dissolve the compound in water. Alright, these two, they are very important for you to understand how to determine preferential discharge of ions. So we are going to get there and then you understand better. So the next thing we want to do is, let's try to look at definition of terms. Certain terms, we try to define them and see what it's about. So number one, so let's try to do this. What is electrolyte? Electrolyte is a compound which decomposes when current goes through. E.g. sodium chloride, Cc. So, if you look at an electrolytic cell or electrolytic cell, the content of that cell, the compound inside the cell, is what you call the electrolyte. It's actually a liquid state, right? And then when current flows through it, it decomposes. Number two, you have the electrodes. What are electrodes? They are metallic rod which allow inflow and outflow of current and electrons in an electrolytic cell. Electrolytic setup. So if I have an electrolytic setup, I have, so let me quickly do this. This is an example of an electrolytic setup, and inside it, so your car battery is an example. You look at your car battery, you see there are two rods on the top of it, and inside the battery you have a fluid substance. If it's a wet cell battery, if it's a wet cell, okay? So in here you can have compounds like tetraazosulfate 6 acid, H2SO4. That's what you have in wet cell battery, H2SO4. Alright, but let's assume we have sodium chloride here for the sake of today's explanation. So you have sodium chloride here. Now this sodium chloride is the compound, is the electrolyte that is going to be broken down. These are the rods. Okay, so these two rods are called electrodes. Electrodes. Then one is positive, the other is negative. So these are the gates through which electric current will enter into the cell and flow out. Alright. So now I'm going to connect this electrolytic setup to a battery. Electrodes. This content, this sodium chloride content is the electrolyte. And of course, this positive electrode is called the anode. Anode. While this is called the cathode. So let me give you an acronym that you can use to remember this. Focus on this. You have panic, and you have care, and then you have announce. So these are the three basic acronyms you're going to use in this topic. Panic. What is panic? If we divide it into two, panic means positive anode. So positive anode. So panic means positive anode. That is, the anode is the positive electrode, while negative is cathode. That is panic. Positive anode, negative is cathode. So when you talk about the cathode, it's the negative electrode, and the positive electrode is the anode. All right. Then what does care? What does it stand for? It means anode. Now at the cathode, this here means cathode. At the cathode, reduction occurs. So reduction occurs at the cathode, while anode means oxidation occurs at the anode. So these are some questions you could be asked. That what happens at the anode, what happens at the cathode? If you look at your electrolysis, redox reaction is occurring. What's the redox reaction? Reduction and oxidation are occurring simultaneously. If you have not seen my video on redox reaction, you can check the description. You will see the link to that video, so you can check it out. Now, redox reaction, reduction and oxidation is occurring simultaneously at the same time. So in this setup, oxidation is occurring, reduction is occurring. So you could be asked, where is oxidation occurring, where is reduction occurring? So reduction is occurring at the cathode, oxidation is occurring at the anode. And of course, the anode is the positive electrode, while the cathode is the negative electrode. Okay, so now, as I have this set up, I've shown you the electrodes. So the electrodes are the anode and the cathode. Now the next thing you want to do is this. Can you see this negative electrode? It is the negative gate to this system. If you can still remember, electrons are negatively charged. So electrons are entering into this setup. You remember we said decomposition will occur when direct current flows in here. This is the source. This battery is the source of direct current. Flows into here, causes the breaking down of this. All right. Now, the current flows in. Now, note this: the current and the electron flows in opposite direction. So, when conventional current is flowing in the clockwise direction, your electron flows in the anti-clockwise direction. So, if current is coming in here, electrons are flowing out through here. Now, this negative gate, this cathode is the negative electrode, is the negative gate through which negativity enters the system. And what is that negativity? Electron. So, your electrons are entering into this cell through here. Electrons are coming. So, and it's coming from the battery, of course. So when the electron enters, it goes out through the anode. So here, electrons are going out. Electrons are going out here. Alright? While current is coming into this place, current is coming in. So let me do this. Current is coming into here. Current is flowing into here. And when the current enters, it flows out through here. So here, current is flowing out. So can you see electrons are flowing in here, and electrons are going out here, while current is flowing in here, right from this source, and it's going out here. So they can ask you, where does the electron come in through? Electron come in through the cathode, and it goes out through here. Where does current comes in through the anode and exits through the cathode? Alright, now, so let's look at the other terms. We have looked at what electrodes are. Let's take a look at what. Now, the next part, the term we want to look at is anode. What is anode? Is the positive electrode. Positive electrode. Right? This is where current flows into the setup and electron exits setup. That's number one. Number two, oxidation occurs here. Oxidation occurs here. How? So now this, let's say this is just sodium chloride in the molten state reacting here. Something will happen. By the time current flows in here, this sodium chloride will divide into Na plus and Cl minus. Then there will be a migration. This anode is positively charged. So one of these will move towards this anode. Which one will move towards it? You remember like poles repel or like poles attract. So to this positive, it is a negative charge that will be attracted to it. Therefore, from this sodium chloride, if I ionize it in this manner, this negative will move towards it, while this positive moves towards it. Now this Cl minus that is coming here, what is it coming here to do? It is coming here, remember electrons are coming in here, going out here. So this is the exit gate for electrons. So once this chlorine comes here, this Cl minus means chlorine has excess electron. There is an extra one electron that is ready to be lost. So chlorine will come here and deposit the electron here so that the electron can flow out. So that loss of electron that occurs here is what we call oxidation. So when we say oxidation occurs here, meaning that chlorine, all right, minus electron, we lose electron to give you green gas. All right. So give out 2 electrons. Yeah. So chlorine gas, we lose electron at the anode, and that is what we call loss of electron. That is reduction. That is oxidation. So how is the oxidation? Here you have negative. The oxidation number of chlorine here is negative, but by the time it gets here, it becomes 0. This minus 1 and 0, that is an increase. So I can rewrite this as Cl minus because I can't have this here. So I'm going to have this Cl plus electron. Okay, so this equation is now balanced. Okay, yeah, better like this. So on this side, it was minus 1, but by the time we got it, that is 0. So this is an increase in oxidation number, and this is oxidation. So oxidation occurs at the anode. Oxidation occurs at the anode. While at the cathode is the negative electrode. Now this is where electrons enter the settle and current exit. And of course from here we said reduction occurs at the cathode. So reduction occurs here. How does reduction occur? This sodium plus comes here, attaches here. Why? Because electrons are flowing in here. So this sodium is coming here. You know, Na plus means there's a deficit of 1 electron. So it's coming here to tap from the electrons that are streaming into the system from here. So by the time it gains 1 electron, it becomes a neutral atom of sodium. And that gaining of electron is what you call reduction. So this is what happens. You have, for example, Na plus, they come and gain an electron, you have Na. So let's see if this is a reduction. Oxidation number of sodium here was +1. By the time it got here, 0. So that is there's a decrease in oxidation number, and therefore it is reduction. So that is what happens at the cathode. Oxidation occurs at the anode, reduction occurs at the cathode. Now the next set of terms I want to talk about, anions, gotten from the word anode ion. You remember anode is a positive electrode and like poles repel or like poles attract. So the charge, or it is a negatively charged ion that will be attracted to the positive anode, meaning that anions are negative ions which are attracted to the anode, e.g. Cl minus OH minus SO4 2 minus. They are examples of anions. While cations mean what? Cathode ions. They are positively charged. They are positively charged. Positively charged ions, and they are attracted to the cathode, which is a negative. They are attracted to the cathode, e.g. H plus, Na plus, Ca2 plus, etc. Alright, so we have looked at what anions, cations, anode, cathode, the electrolytes, electrodes. We've looked at the meaning of them. And of course, this is an electrolytic setup. So this is an electrolytic setup. Electrolytic cell. I call it electrolytic cell. That is where the electrolysis takes place. So that is what happens here. Now this is the first part of the first set of information you need to understand from this topic. The second part of this, I'll be talking about what happens here, how to determine which ion will be preferentially discharged by the time current passes through. Because by the time this is in molten state, that is why you have just two. If it's in aqueous solution, that means I will dissolve this sodium chloride in water. And by the time I have to decide, I will now have 4 ions to battle with. Out of the 4, only 2 will be discharged. How do I determine the 2 that will be discharged? That is why you need to watch out for the next video I will drop on this topic. So in the second video, I'll be talking about how to determine which ion will be preferentially discharged. And in the third video, I'll be talking about the calculation aspect of electrolysis. And I'm going to give you a shortcut, just as I've done here. I'll be giving you acronyms and shortcuts that you can easily use to solve calculations on electrolysis. Both the first Faraday's law of electrolysis and the second Faraday law of electrolysis. I'm going to give you a shortcut for all of that. To make the calculations very, very easy for you. I want to believe you've gotten value today. If you have not subscribed to our channel, do well to subscribe right now and share this video with your colleagues, and then you can go to the comment section and drop your comment. How do you feel about this class? Would you still like, maybe you have a question? Drop it at the comment section. I will be right there to give you a response to your question. Thank you for being a part of today's class. Bye for now.